Okay, here we are. Today we are talking about adding and subtracting radicals. Okay, so far we have looked at perfect roots, we have looked at simplifying radicals, and now we are moving into this other piece. So, if I ask you guys what 5x plus 2x is, it's what? 7x. Okay. It works the same exact way with radicals, meaning you have to have the same exact radical to be able to add or subtract them or combine them, okay? So just like we combine like terms, we combine like radicals as well. So with that knowledge, if I have 5 root 7s and I add 2 root 7s to it, how many root 7s do I have total? 7. So it's 7 root 7. Okay, next. 17 root 3 minus 1 root 3 is how many root 3s? 16 root 3. Next, I think we all can agree that the square root of 8 is not the same thing as the square root of 32. But does anybody have a suggestion as to how we might be able to get them to be the same? Lydia? Okay, so we can rewrite, so, wait, what? Say that again. Okay, so good. So this is the square root of 4 times the square root of 8, and this one is the square root of 4 and the square root of 2. Is that what you said? Okay, perfect, good. So this one, once we separate it, the square root of 4 is what? 2. So it's 2 root 2 plus 2 root 8. So we're getting closer, but they're still not the same. So now what? Do it again. Good. How? 8 is 2 and 4 again. Okay, so 2 root 2 plus 2 times root 4 times root 2. So this becomes 2 times 2, which is 4. So 2 root 2 plus 4 root 2 is how many root 2s? 6 root 2. Now, you also could have in the beginning, this is why we say if you're using this method, to look for the largest perfect square within each number. Because we also could have done 16 and 2 to start out with, and then we would have left out a couple steps. Okay? Questions? Can I move this? Okay. Next one. 5 root 2 times minus root 63. Same idea, right? Can anybody think of how we might be able to break up 63 into something times something else of which one is a perfect square? Akashni. Cool, everybody give it up for Akashni. We didn't do that for Lydia either. Give it up for Lydia. For the problem we just did. Okay. What's the square root of 9? 3. Okay, now what? What do you guys think? Can we do anything else? No. Okay, so we just leave it like this. Sometimes that happens. It doesn't happen often, but it does happen to where even after we simplify it, we can't combine them, and that's okay. Okay, so here we go. Now we have some cubic roots to deal with. So, okay, so now instead of looking for perfect squares, we're looking for perfect cubes to rewrite these so we can simplify it and so on. So can anybody, let's look at 16 first. Can anybody think of a perfect cube? 4 is a perfect square. That's good. Perfect cube, so a number you multiply by itself 3 times. Or we can do the factor tree here too if you want. You guys want to do the factor tree? Yeah? Okay. 16 is 2 times 8, 8 is 2 times 4, 4 is 2 times 2, right? In fact, let's do both factor trees while we're at it. Okay, what is 54? What times what? 9 times 6. 9 is 3 and 3. 6 is 2 and 3. So let's rewrite both of these in numerical order. So this one, we have 4 2s. 1, 2, 3, 4. This one, we have a 2 and 3 3s. Okay, so since we're dealing with a cubic root, we're looking for how many? Triples. So we have a triple of 2s and a triple of 3s here. And you can see that what's left over underneath the radical is the same, so we will be able to combine them when we're done. Kendra? Perfect. And then if we do the same thing with this, we end up with what on the outside? Perfect. Okay, so then we multiply it by what is already existing out there. 2 times 4 is 8 times the cubic root of 2 plus 9 cubic roots of 2 gives us how many cubic roots of 2 overall? 17 cubic roots of 2. Very good job, you guys. Give yourselves a round of applause. It's going fast. Questions? Christian. Why on the first one what? Because when we broke down our factor tree, the prime numbers that we were left with were 4 2s. Oh, right here? Oh, because when we broke down the number 54... Never mind. Oh, why did we do 3 instead of 2? Okay. Yeah, because we're dealing with a cubic root... Zip it. Because we're dealing with a cubic root. So dealing with a cubic root means we need triples of numbers. Because here, 2 times 2 times 2 is 8, right? The cubic root of 8 is 2. Is why it comes out. As opposed to with a square root, you're looking for squares or 2s. Does that make sense? Whoever asked that question, does that make sense? Okay, here we go. We have this set of examples and then one more, and we're done. Okay, 5 plus root 2 times 5 minus root 2. This is everybody's favorite FOIL scenario. Yeah. F-O-I-L, or box if you prefer the box. Okay, so let's work through here. Yeah, those people who prefer the box, do it on your own. Okay, I'm going to do the...
Is that an S or is that a 5?
That sounded kind of brutal. But seriously, do it on your own. We're going to do FOIL again. Only because when you all get to pre-calculus next year, you are going to have to know FOIL and at like warp speed, okay? So, here we go. 5 plus root 2 times 5 minus root 2. The first ones, 5 times 5 is 25. Okay, then the outer, 5 times negative root 2 is negative 5 root 2. Then the inner, 5 times positive root 2 is 5 root 2. The last, positive root 2 times negative root 2 is negative root 4. What is the square root of 4 again? 2. What happens to the negative 5 root 2 and the positive 5 root 2? They cancel. I want you guys to keep this in mind as we go to the next problem. We ended up with 25 minus 2, which is what? 23. Okay. We're going to be asked to rationalize more denominators, but denominators that look like this, that are binomial products. Okay, so we want to keep this process in mind. All right, let's get a little bit more practice with that. Are you all so in love with the box that we should do the box on this one?
No.
Okay. All right. Since we actually have cheering for FOIL, let's do FOIL. Okay, here we go. So let's see. First, outer, inner, last. Let's move this up. All right, so when I multiply the first ones together, root 3 times 3 root 5. Lydia, you want to do it or is that a question? Yeah. Yes. Yeah, so let me just, so you all are aware, the reason that it appears that I might be losing my hearing while I'm up here is this thing is super loud, our heater. Those people that are sitting near me can hear it too, and it is really loud. So if you're talking at your regular talking voice over there, I literally cannot hear you. It sounds like a bunch of muffles. So, Lydia, can you yell what your question was, please?
Okay. The two middle ones with the O and the I.
Yes.
They just cancel out really right again?
Right, because they're opposites of each other. 5 root 2 minus 5 root 2 is what? It's 0. So that's, yeah, keep that in mind. We're going to use that in a little bit. Again, Hannah.
So this example that you did, the first one said 5, but you wrote the 3.
Thank you. Okay, thank you. Other questions or comments? Yes?
So when you have something that has the same radical,
Yeah.
and it's subtracting, and the first number is smaller, do you just change it to negative just like regular math?
It works like regular math, yes. Okay, here we go. Root 5 times 3 root 5. That is 3 root 25. Outer, we have root 5 times negative root 6. That's negative root 30. Then the inner, 2 root 6 times 3 root 5. That is 6 root 30. And then the last one, we have 2 root 6 times negative root 6. That is negative 2 root 36. So now if we go through and simplify all of these, the square root of 25 is what? 5. So this one becomes 3 times 5, which is 15. We can combine these two right now because they both are radical 30s, correct? So negative root 30 plus 6 root 30s is how many root 30s total? 5. So plus 5 root 30. This last one, what does this one come out to when you take the square root and multiply? 6. So negative 2 times 6 is 12, negative 12. Okay, good. So now, if we go and combine the like terms that we have, we end up with what? 3. So 3 plus 5 root 30. You always want to make sure that you have simplified as much as you possibly can. Is there anything that we're able to do with 30? We know we can break it down into 10 and 3 and 2 and 5, but beyond that, if that's what we're left with, do we have any pairs? No, so we can just leave it like that. All right, how are we doing on questions? Okay, everybody take a picture of this in your mind, or at least you have it on your notes in front of you. That would be easier. Okay, rationalizing the denominator again. So from yesterday, we talked about rationalizing the denominator. Anybody remember what that means? Marcy.
To multiply it by the denominator, like it's on top of it.
Right. When you have a monomial in the denominator, you multiply it by itself. Okay, nobody should be talking, or if you're talking, I shouldn't be able to hear it. Shh. Okay. So the whole goal in rationalizing the denominator is to get rid of any radicals, okay? I'm going to put this back up here one more time so you all can see, or hopefully use this to help you out. I want you guys to notice something about the things that were multiplied in this first example and what happened at the very end, what we got as an answer. Okay, so we did 5 plus root 2 and 5 minus root 2, and when we multiplied those together, we ended up with no radicals, correct? Yes? Okay. So if we apply that same concept to this problem, can anybody take a guess at what you think we're going to be multiplying the numerator and denominator by? Kendra? Excellent. Everybody give it up for Kendra. 3 minus root 6. Okay. So these are 3 plus root 6, 3 minus root 6. Those are what are called conjugates. So conjugate is a word to describe exactly what you see here. So the first term is the same and the last terms are the same, except the only difference is that one is positive and one is negative. Okay. Ooh. Yeah, okay, I'll be with you in a minute. This is our last example. Okay. So when we do this, when we multiply this through, if we distribute, 2 times 3 is 6. 2 times negative root 6 is negative 2 root 6. On the bottom, think about foiling it out. We get 3 times 3 is 9. The outside is negative 3 root 6. The inside is 3 root 6. Whoops. And the last ones are negative root 36. All right, so what happens to the middle two terms? They cancel. Whoops. So these two go away. And what is the square root of 36? 6. 9 minus 6 is 3. So we end up getting 6 minus 2 root 6 over 3. All right, questions? Okay. You guys have your homework assignment right here. Everybody go ahead and get going on that.